This course module deals with security auditing and explores the most important security standards in the energy sector. Upon completion of this module, students will be able to understand security audit terminologies, describe the stages of a security audit, describe the need for a security audit, evaluate security controls and evidence, and gain a general understanding of the NERC CIP standards. This section covers the basic concepts and terminologies on security compliance and auditing, and the need for compliance and auditing. Security compliance is the process of ensuring that the organization is meeting all of the requirements imposed by regulations, industry standards, security policies, and business objectives. Security assessment is the evaluation of security controls to determine the extent to which the controls are implemented correctly, operating as intended, and producing the desired outcome with respect to meeting the security requirements. NIST SP 800-712A. Security control is a safeguard or countermeasure prescribed for an organization designed to protect the three tenets of security: confidentiality, integrity, and availability of information, and to meet a set of defined security requirements. This definition is from NIST SP 1800-15B. Security assurance is the measure of confidence that the security features, practices, procedures, and architecture of an information system accurately mediates and ensures the security policy. NIST SP 800-39. Security audit is an independent review and examination of records and activities to assess the adequacy of system controls, to ensure compliance with established security policies and operational procedures. NIST SP 800-12, Revision 1. Compliance audit is a comprehensive review of an organization's adherence to the requirements of a standard, regulation, or policy. Let us differentiate security audit from security assessment. Security audit is more rigid than security assessment. Security audits are conducted with more rigor by qualified personnel. A qualified personnel is usually a certified auditor. The organization typically receives certification upon passing an audit. Auditors do not get involved with auditing processes or policies that they have designed or implemented. Typically, an audit is an independent evaluation conducted by external entities. Now, let's talk about the need for a security audit. Security audit is necessary to 1. Identify security gaps and vulnerabilities. An example is a security audit on firewall configuration, which may reveal some weaknesses in firewall rules. Number 2. Establish a security baseline. Establishing a security baseline may help in continuous improvement. Number 3. Ensure compliance with security policies. An audit may reveal that some security policies are not enforced. Number 4. Ensure compliance with regulatory requirements. Ensuring regulatory compliance through audit may prove beneficial to the organization. Number 5. Enhance existing security policies or create a new security policy as needed. Audit may reveal some gaps in a security policy and induce the enhancement of the policy. Number 6. Identify unnecessary processes or resources. An audit may not reveal only gaps, but also unnecessary or dated processes which are consuming valuable resources. The scope of an audit may include one or a combination of the following. Organizational, examines management controls and other related policies and procedures necessary to conduct business. Compliance, ensures that specific guidelines and requirements of regulations, standards, or policies are met. This may be specific to the nature of the organization's business. Application pertains to strategic goals such as those involving finance and operations. Technical pertains to the information technology systems and data. With business operations heavily dependent on technology, technical audit becomes an integral component of the other types of audit. The stages in a security audit are the following. First, agree on an audit goals, scope, and engagement. Then, pre-plan the audit. Next, perform an audit risk assessment. Then, perform the actual security audit. During the audit, evaluate security policies and controls. Next, analyze the results and prepare an audit report. Finally, determine the needed controls, state your opinions, and/or recommend necessary improvements. When securing the agreement on audit goals, scope, and engagement, ensure to include all stakeholders in establishing the audit goals and scope. Identify liaison personnel for auditing purposes within the organization. Establish responsibility, authority, and accountability. And obtain the approval of the audit engagement agreement outlining the scope, responsibilities, authority, and accountability. On pre-planning the audit, you need to do the following. Know the business and its operations, identify key personnel, identify resources and assets, gather previous audit reports, plan each audit to accomplish specific objectives, develop schedule of events, provide audit cost estimates. The next stage in the audit process is to perform an audit risk assessment. It involves the following. Identify critical assets and services of business operations. Identify threats that must be addressed. Identify vulnerabilities. Determine security controls, current, future, and issues involved. Determine internal capabilities of personnel. Document risks and probabilities of their realization. Calculate financial and operational impact of the risks. Can they be mitigated, transferred, or accepted? And determine security controls needed to mitigate or minimize the risk. Now we come to the actual security audit. First, create an audit personnel resource plan and allocation. Then enforce audit quality control by using audit performance metrics, by being considerate of business timings and operations, by being responsive to audit questions and complaints, by holding audit awareness workshops for the personnel involved. Next, develop clearly structured communication channels. Make sure to always utilize sound and precise data collection techniques. And finally, identify, analyze, and document useful evidence. Also during the audit, make sure to review existing security controls of the following. Prevention types include access controls, data backups, and service level agreements, SLAs. Detection types include security and system logs, intrusion detection systems, alarms, self-risk assessments. Correction types include business recovery plans, incident response plans, hot or warm sites, redundant networks and systems, and load balancing. In evidence collection, consider the types of audit evidence, which are direct evidence, which proves the existence of facts without inference, and indirect evidence that uses hypotheses to infer certain facts. During the collection and analysis of evidence, recognize the following grades of evidence. Material relevance. Note that materially relevant evidence establishes facts. Evidence objectivity refers to the ability to be accepted and understood with very little judgment involved. Competency of evidence provider. This essentially establishes the fact that evidence supplied by someone who has direct involvement is more credible. Evidence independence. This implies that the provider should not have any gain or loss in providing the evidence. The evidence life cycle is depicted in this chart. It starts with the initial discovery of evidence, which is going to be identified and documented. Next, the auditor needs to take possession of the evidence and place it under the control of a custodian. The chain of custody procedure needs to be followed during the movement of material evidence. The preservation and storage processes are the next steps, followed by an analysis of the evidence. During the analysis stage, the evidence is examined by observation, scientific test, and qualitative and quantitative measurements. These should be properly documented. After the analysis, the evidence is returned to preservation and secure storage. The next step is the presentation, in which the auditor presents the evidence and findings. Finally, the evidence is returned to the owner after all proceedings, legal or technical, are completed. The audit findings report includes the audit scope, objectives, methods and criteria used, detail of findings, auditor opinions, auditor concerns or reservations, standards followed, extent of work, and applicable dates of coverage. The following section examines the North American Electric Reliability Corporation Critical Infrastructure Protection, also known as NERC CIP. The Critical Infrastructure Protection CIP set of standards is developed by the North American Electric Reliability Corporation, NERC, to ensure the protection of assets used to operate North America's bulk electric systems, BES. An entity that owns or operates any type of BES in the United States and Canada must be compliant with the requirements of the NERC CIP standards. A closely related set of standards is the International Society of Automation, International Electrotechnical Commission, ISA-IEC, 62443 standards, which addresses the security of industrial automation and control systems, IACS. Purpose of CIP 002-5.1a is to identify and categorize BES cyber systems and their associated BES cyber assets for the application of cybersecurity requirements commensurate with the adverse impact that loss, compromise, or misuse of these BES cyber systems could have on the reliable operations of the BES. Identification and categorization of BES cyber systems support appropriate protection against compromises that could lead to the misoperation or instability in the BES. The purpose of CIP 003-8 is to specify consistent and sustainable security measurement controls that establish responsibility and accountability to protect BES cyber systems against compromise that could lead to misoperation or instability in the bulk electric system, BES. Each responsible entity shall review and obtain CIP senior management approval at least every 15 calendar months for one or more documented cybersecurity policies that collectively address topics such as personnel training, physical security, system security, and management recovery plans, among others. The purpose of CIP 004-6 is to minimize the risk against compromise that could lead to the misoperation or instability in the bulk electric system, BES, from individuals accessing BES cyber systems by requiring an appropriate level of personnel risk assessment, training, and security awareness in support of protecting BES cyber systems. Requirements include periodic cybersecurity training programs. The purpose of CIP 005-7 is to manage electronic access to BES cyber systems by specifying a controlled electronic security perimeter in support of protecting BES cyber systems against compromise that could lead to misoperation or instability in the BES. One requirement is to have all external routable connectivity go through an identified electronic access point. The purpose of CIP 006-6 is to manage physical access to bulk electric system BES cyber systems by specifying a physical security plan in support of protecting BES cyber systems against compromise that could lead to misoperation or instability in the BES. One requirement is to define operational or procedural controls to restrict physical access. The purpose of CIP 007-6 is to manage system security by specifying select technical, operational, and procedural requirements in support of protecting BES cyber systems against compromise that could lead to misoperation or instability in the bulk electric system BES. One requirement is to implement a patch management process for tracking, evaluating, and installing cybersecurity patches for applicable cyber assets. The purpose of CIP 008-6 is to mitigate the risk to the reliable operations of the BES as the result of a cybersecurity incident by specifying incident response requirements. One requirement is to implement incident response handling procedures for cybersecurity incidents. The purpose of CIP 09-6 is to recover reliability functions performed by BES cyber systems by specifying recovery plan requirements in support of the continued stability, operability, and reliability of the BES. One requirement is to implement one or more processes for the backup and storage of information required to recover BES cyber system functionality. The purpose of CIP 010-4 is to prevent, and detect unauthorized changes to BES cyber systems by specifying configuration change management and vulnerability assessment requirements in support of protecting BES cyber systems from compromise that could lead to misoperation or instability in the bulk electric system, BES. One requirement is to monitor at least once every 35 calendar days for changes to the baseline configurations. The purpose of CIP 011-2 is to prevent unauthorized access to BES cyber system information by specifying information protection requirements in support of protecting BES cyber systems against compromise that could lead to misoperation or instability in the bulk electric system, BES. One requirement is to implement a BES cyber asset reuse and disposal procedure. The purpose of CIP 012-1 is to protect the confidentiality and integrity of real-time assessment and real-time monitoring data transmitted between control centers. Requirement is to implement documented plans to mitigate the risks posed by unauthorized disclosure and unauthorized modification of data transmitted. The purpose of CIP 013-2 is to mitigate against cybersecurity risks to the reliable operation of the bulk electric system, BES, by implementing secure controls for supply chain risk management of BES cyber systems. One requirement is to develop one or more documented supply chain cybersecurity risk management plans. The purpose of CP 014-3 is to identify and protect transmission stations and transmission substations and their associated primary control centers that, if rendered inoperable or damaged as a result of a physical attack, could result in instability, uncontrollable separation, or cascading within an interconnection. One requirement is to perform an initial risk assessment and subsequent risk assessment of transmission stations and substations.